Okay, same guys. So on the heterocyclics, let's talk about the fused rings, where one ring is benzene and where all rings are heterocyclics. Here we have structures which we are using as examples. Here the structures, one ring is benzene, another ring is heterocyclic. How do we name it? Or how do we name them? For the rings where benzene is part, it will be benzo. Then we put the face where the fusion is. Put the face or the fusion. Then we give the heterocyclic name. So that's how we are going to name them. We put benzo to put the face where the fusion is, then heterocyclic name. For example, this structure, we have benzene and this structure is pyridine. So this one will be benzo. Now, for the fusion, we name or we label the faces alphabetically from the first atom of the heterocyclic. So this one is A, this one is B, you have C, D, E, and F. From the first atom or from the heteroatom. So, meaning that this is benzo B. Benzo B. Pyridine. It is benzo B. Pyridine. For this one, it will be benzo. This is A. We label towards the fusion, in the direction towards the fusion. Even this one, it was like this. So, you label towards the fusion. This is B, C, D, E, and F. So, we cannot go this side because this one is a long route to the fusion. But this one is the shortest route to the fusion. So this one will be benzo C. Then you put in the square brackets. Benzo C, pyridine. Sometimes you can use the IUPAC name for the heterocyclic. This is a common name. Remember, we talked about the common names and the IUPAC names. So, and a common name for the whole ring, this ring is known as quinoline. Quinoline. Remember in the video, this one is isoquinoline. So you can use this or just give them the common names. But this is the way we name them. Benzo, then the face, the heterocyclic. Then we have this structure. Remember the common name for this structure is indole. Is indole. But we can name it like benzo. Then this is FS, this is B, C, D, and E. The fusion is at the B phase, so it is benzo B. Then this structure alone, this heterocyclic, this one is known as pyrrole, so it is benzo B, pyrrole. Benzo B, pyrrole. Or you can use IUPAC names. For example, say that this one will be aza, then, or so it is azo. You can say benzo B, azo. It can work. Or indole. All of them are names for these heterocyclics. Now, we have this side. We have heterocyclics. Like both rings are heterocyclics. Both rings are heterocyclics. What are the rules? One, if you have a ring, containing nitrogen, it is considered first. So nitrogen considered first. So you choose one ring to be a parent ring. So we have a minor ring, then you put the fusion, the point of fusion, then you name the parent ring or the major ring, parent ring. But to choose the ring, first you consider, if you have a ring containing nitrogen, to be considered the parent ring. That's one of the rules. Let's see this example. We have this ring and you have this ring. Mean that this ring will be considered the parent. This ring will be considered the parent ring. This is the minor ring. And this one is thiophene. This one is pyrrole. You see, this is thiophene, this is pyrrole. For the parent ring, we name them alphabetically. Parent ring, we shall name them alphabetically. Alphabetically from the atom, from the heteroatom towards the fusion. So from heteroatom towards the fusion. Then for the minor ring, you just number them. We go by numbering. Like we give them the integers. So numbering also from the heteroatom towards the fusion. So meaning this is position. If this is the heteroatom, this one will be A, face A. Then face B, face C, and face D plus face E. So we have A, B, C, D, E. Those are the faces. For the minor atom, for the minor ring, this is position 1, remember? So this is 1, this is position 2, 3, 4, then 5. For it, you name positions 1, 2, 3, 4, 5, but for the parent, you just label the faces as A, B, C, D, like that. So this is the way we name them. This one will be minor ring is thiophene. But if you have a name for the minor ring, ending with E, if it ends with E, if the name for the minor ring ends with E, we change this E to O. For example, if you have pyrrole, we shall name it pyrrole. So this one changes to O. Now these ones are exceptions. These are exceptions. For the rings, if it ends with E, you change it to O. But for these ones, there are exceptions. For example, imidazo is like this, imidazo. But we just remove the E to imidazole. To be imidazole. For furan, you just remove N and this HN2, so it is furo. This is pyridine. To be pyrido. In case it is the minor ring. In case they are the minor rings. We have this one. Pyrimidine. Will be pyrimido. Then quinoline will be quino. Isoquinoline will be isoquino. This is isoquinoline. To be isoquino. But others, in case you have pyrrole, to be pyrrole. So don't forget that. Now, for this structure, we have thiophene and we have pyrrole, but pyrrole is the parent, so we don't need to change the E. So it will be thiophene. The ring will be, now thiophene, we say that the E will be changed to O, so it is thiopheno. Then positions, this is 1, 2, 3. And here we have fusion and position 2, 3. Position 2 and 3 plus the face B. 2, 3 and face B. That's why we have the fusion. But we shall write 3 to B. Because 3 is near the first atom of the parent structure. So we begin with the 3 because it is near the first atom of the parent structure. So it will be thiopheno 3, 2. 3, 2, then face B of what? Of pyrrole. It will be like that. So at first, you consider N. If any ring is having nitrogen, it will be considered first. Let's remove these ones. Then, we said at first you consider nitrogen. Secondly, if you don't have nitrogen, then the order should be from group 7. Like the higher the group, the more the priority. So group 7 will be more than group 5. Group 6. Group 7 will be more than group 6 and will be prioritized more than group 5. Like that. So, mean that in group 7, fluorine will be more prioritized than chlorine, then bromine, then iodine. Then after group 7, then you go to group 6. So in group 6, mean that oxygen will be more prioritized than sulfur. I'm saying it's more prioritized than sulfur. So like that, then you go to group 5. In group 5, then you go to the phosphorus. Get. Now here we have these 2 rings, but we have oxygen and sulfur. So oxygen is prioritized than sulfur, meaning that to be the parent structure. To be the parent structure. This is furan, and this is thiopyrene. We say that the minor ring, we give it numbers. So this is 1, 2, 3, 4, 5, 6. Then the major ring, we name the faces from the heteroatom. This is A, and towards the fusion, this is A, B, C, D, and E. So the name will be thiopyrano. Replace the E with O. So thiopyrano. Fusion is at position 2, 3. But 3 is near the first atom from the parent ring. So it is 3, 2. Then at face B. Then we write furan. So it is thiopyrano 3, 2B furan. Now, those are two rules. The third one, here we're having both heteroatoms having oxygen. They are both having oxygen. Now we consider the bigger ring. So the bigger the ring, the more priority is given. So mean that this one will be more prioritized. This is 5-membered, 5-membered, this is 6-membered. And this is pyran. This is pyran. And this one is furan. This one is furan. But we have a saturated carbon. So it is 2H furan. It is 2H furan. So this is what we have. Now the name will be furo. Said here is furo. Now the fusion, this is position 1. This is 2. This is 3, 4, and 5. For this one, this is A, B, C, D, E, and F. So we shall write furo, then at position 3, 2. So it will be 3, 2, B. Then write pyran. But we also consider the saturated atom. The saturated atom is considered. Now, if we are numbering the whole system, we shall begin from this position. This one will be 1, 2, 3, 4, 5, 6, 7. So at position 2, we are having a saturated atom. So it is 2H, furo, 3, 2B, pyran. So this one is given after considering the whole system. Remember, we talked about numbering. So this one will be position 1, not this one, because you want to give lowest locant to the saturated atom. Now, when it comes to this one, the fourth rule, here we have nitrogen and here we have nitrogen. So mean that this one, we shall skip it. Rule 1, we shall skip it. And here we have oxygen, but here we have only nitrogen. So this ring is having 2 heteroatoms. This one is having 1 heteroatom. So we go with the greatest number. The greatest number of heteroatom. So we go with the greatest number of heteroatoms. Now, parent ring, and this is oxazine. It is oxazine. And this is position 1. If you are considering the priority, remember it's different from the previous video. This will be position 1. This is 2, 3, 4, 5, 6. So at position 1 and 2, we have heteroatoms. 1, 2, oxazine. Then this one is pyridine. is pyridine. And since this one is position 1, we are moving this direction towards the fusion. So this will be F phase, B phase, C, D, E, and F. For the minor ring, this is position 1, this is 2, 3, 4, 5, and 6. We label the atoms. But for the major ring, we label the phases, not the atoms. So it should be this direction towards fusion and also this direction towards fusion. So this one will be pyrido. From here, pyrido. Then, since this one is moving this direction and this one is moving this direction, 2, 3 is in the same direction as the parent structure. So it will be 2, 3, not 3, 2. This one will be moving in the different direction to be going this side. But for the major ring, yet it is moving this direction. So it will be 2, 3 because it's moving towards the same direction with the major ring. So it is 2, 3, D. At 2, 3 and first D, we have a fusion. Then 1, 2, oxazine. That will be the name for this heterocyclic. Now, we have this one. We have this one. Now, the fifth rule, here we have nitrogen and nitrogen. Here we have oxygen and nitrogen. So, we have the same numbers for both heteroatoms, for both heterocyclics. We have 2 and this one is having 2. Now we go and consider the variety. The variety of heteroatoms. Will be prioritized. So this one is having oxygen and nitrogen, but both of these ones are nitrogen atoms. So this one will be the parent ring. This one will be the minor ring. So this is oxazo. Oxazo. Sometimes you can give it the locants. This position 1, 2, 3. It is 1, 3, oxazo. But even if you don't put these ones, because oxazo, it is at position 1 and 3. In case it is position 1 and 2, that is isoxazo. But oxazo, it is 1 and 3. But sometimes they put the locant. Then this one is pyrazo. Is pyrazo. So you have oxazo and pyrazo. This is position 1 for the parent structure. This is 1, this is 2, 3. Meaning that we shall label phases towards this direction. So this is A, B, C, D, and E. Then for pyrazo, before fusion, this is position 1, and this is 2, 3, like that. But because they are fused, we shall give the lowest locant to the heteroatoms and lowest true to the fusion. So this one will be position 1, 2, 3, 4, and 5. So the name will be pyrazole. It's now pyrazole. We replace the E with O. So it is pyrazole. Fusion is at position 3 and 4 and the first D. But since this one is moving in this direction, like this, yet this ring, we are moving this direction, we shall change. Instead of 3, 4, we shall write 4, 3 because we want to move in the same direction. So it will be pyrazole 4, 3, 4, 3, and first D. That's where the fusion is. So it is pyrazole 4, 3D, then 1, 3 oxazole. So that one will be the name for this heterocyclic, pyrazole 4, 3D, 1, 3 oxazole. But for the ring containing nitrogen, for the ring like pyrrole, pyrazole, for them, they cannot exist naturally, like without one of their heteroatom having saturated nitrogen. Now, for them, they are labeled before numbering the whole system. You give the position of the saturated atom. So this one will be 1H. 1H at position 1H. At position 1 of the pyrazole. This was position 1 before fusion. So 1H pyrazole, then complete the name for the pyrrole, pyrazole. You give the position of the saturated atom first for the saturated nitrogen. But here we gave it after fusion, like number in the whole system is position 2. Though even before fusion it was position 2. 2H, sure, then 1H pyrazole. Now we have the structure. This is thiazole. And this is oxazole. This is oxazole, this is thiazole. Now, here we have variety. We have sulfur and nitrogen, we have oxygen and nitrogen. But the order will go by group 6. Okay, group 7, then will be greater than group 6, then group 5, like that. So, this oxygen is in group 6. Also, sulfur is in group 6. But oxygen is first in the periodic table, as we said. In the same periodic table, then the priority decreases down the group. So, since the ring all contain nitrogen, rule 1 is skipped. And they have all of them, they have variety. But oxygen is more prioritized than sulfur. So, this is the major or the parent ring. Therefore, this is position 1, 2, 3, 4, 5. So this will be A phase, this is B phase, C phase, D phase, and E. For thiazole, this one will be position 1. We are giving lowest locants to the heteroatoms. And if we start from this one, it will give us same locants, and from this one will give us same locants. But sulfur is prioritized than nitrogen according to this rule. And remember, numbering, we talked about it. Please watch that video before this. This one is position 1, this is 2, this is position 3. Let's see, then 4 and 5. So it will be thiazole, to be thiazole, then fusion is at, so this one is moving this direction, then for this one is moving this direction, they're in the different direction. Therefore, instead of labeling 4, 5, it will be 5, 4, because you want to move this direction. So this one will be 5, 4, not 4, 5. So it is 5, 4, D, oxazole. So this is the name for this heterocyclic. Now we have these ones. we have pyrazine and pyridazine. We have pyrazine and pyridazine, but they all have nitrogen atoms. Now, rule 7, we consider lowest locant of heteroatoms. For this one, nitrogen is at position 1 and 2. But for this one, it is position 1 and 4. So this one will be taken as the parent structure. To be taken as a parent structure. Therefore, the name now, if you're labeling this one will be position 1, 2, 3, 4, 5. So the faces will be A, B, C, and D. And D. Then when you're labeling this one will be position 1, this is 2, 3, 4, 5, and 6. So it will be pyrazino 5, 6, 5, 6 D of what? Of pyridazine. Pyridazine. So that's the name. Pyrazino 5, 6 first D. Then we have this structure. This structure, we have a fused heteroatom. We have a fused heteroatom. But for this, if you find such structure, you take the fused nitrogen or the fused heteroatom as part of like both rings. If you take this ring, it should be part of it. And if you take this ring, it should be part of it. So if you consider this ring, this one will be thiazo. It will be thiazo. And if you take this ring, it will be imidazo. It is imidazo. I think. So when you are naming, therefore, this one will be having variety. So this one will be taken as a parent structure because it has variety. It has sulfur and nitrogen. This one is having nitrogen and nitrogen. So this one will be position 1, 2, 3. Therefore, the faces for the parent structure will be A, B, C, D, and E towards that direction. So there, towards this direction. Then for this one, since this nitrogen is far from fusion, this one is near the fusion. So this one will be considered first. It will be 1, this position 2, this one will be at position 3, then 4, 5. Therefore, the name will be imidazo, like this. Then, since this one is moving, we are moving this direction. By this one, we are moving the other direction. Instead of 1, 2, we shall write 2, 1 because we want to move this direction. So they should be both moving outwards. So this one will be 2, 1, 2, 1, B. So it is imidazo or imidazo 2, 1, B. Thiazo. Sometimes they put here 1, 3, thiazo. But of course, for thiazo, it is at position 1 and 3. So there's no need to put this. Though, even if you put it, it remains the same. So it is midazo to 1b thiazo. We have seen how to name FUSED rings or FUSED heterocyclics. We saw where one is benzene ring and where both are heterocyclics. Now, we have these structures here. We have these structures. I'm sure you can try them out using the same principles. You can consider this as one ring, then this as benzene ring. Also, this one as one, this one as one ring, then this one as another ring. Though we shall make videos about how to name the tricyclic heterocyclics, but you can try them out. Please put the answers in the comment section. Yes, Sam the guy. Thanks for watching. Please don't forget to share, like the videos. Thanks so much.